Okay, guys. This video is from lecture 11.6, and in lecture 11.6, I will be going back and forth. I'm going to use the PowerPoint because the PowerPoint has the word problems, which is available to you. So you will have a PowerPoint. Some problems will be solved. Some of them are not solved on the PowerPoint. That's why also I'm going to use the notes to solve those problems. So we in Unit 2, okay, so far you have a lecture from 11.2, 11.3, 11.4, and next section it's section 11.6, and I'm going to use the PowerPoint to explain the problems. So you can find the PowerPoint right here. However, I'm going to upload also this lecture and my notes from OneNote. Okay. So 11.6, it's about application of linear equation and modeling. So here what we're going to do, we're going to actually learn how to interpret the linear equation in real life world problems. Okay, so PowerPoint. Okay, so you guys have this PowerPoint. And 11.6, again, that's the word problems. And it's going to talk about how to interpret the linear equation in two variables. So linear equation can often be used to describe the relationship between two variables in the real world problems or events. Okay. And again, don't forget that we're going to use the equation y is equal mx plus b. Doesn't work that way. Okay. So let me write down notes for you guys. Okay, so we're going back to the linear equation, slope y-intercept. So y is equal mx plus b. Okay, we talk about that. This is the slope-intercept form. And when we're solving the word problems, what is important that the slope, again, our coefficient in front of x, is called a rate of change okay. The term b, which is again in the equation y-intercept, will remain constant regardless of value of the value of x. Okay, so the term b, I want to talk first about term b. Usually that's going to be something like one-time fee, okay, service charge. Okay, so that's going to be the term b, which is just a constant. The slope, it's our rate of change. So let's say that can be how much you paying per service monthly, or okay, or with old-fashioned cell phones, when we used to pay for minutes we've been talking. So that slope will be, let's say, how much we pay for a minute of talking on the phone. Okay, so I will go first to the example one. So that's going to be the example one from the PowerPoint. Let me log in and show you that example. Okay, so right here, this is the example one. And in example one, you guys see the equation of the straight line. Okay, so we have equation of the straight line, y is equal negative 350x plus 42,000. And the graph is given for you. And like you guys see, on the x-axis, x represents year, but what you have to notice that when x equals 0, that means here we're starting with the year 1900. So 15 right here will be 1915, and then 30 will represent 1930, and so on. So again, it's very important to read that information. So 0 doesn't mean like 0 year, that means 1900. So we're starting this graph from 1900s, and we're talking about the number of tigers in India by year. So on the y-axis, you're going to see the number of tigers in India. So when x is equal to 0, which means in 1900s, we had 42,000 of tigers. And like we see that the line goes down, so the tigers, the amount of tigers decrease, okay? So let's talk about this one. So since the year 1900, so that means the tiger population starting from 1900 was 42,000, and the number of tigers decrease. Okay, recent studies show this decrease can be approximated by the equation y is equal negative 350x plus 42,000. The variable y represents the number of tigers left in India, and x represents the number of years since 1900. Okay, so that's the problem. Okay, so what we're going to do first. Okay, so I will be going back to that graph. I wonder if I can copy and paste that graph. Most likely not. Let's see. No, it won't. Okay. Let's write this down. So example one in A. In A, they're going to ask you, use the equation to estimate the number of tigers in 1960. Okay, so we're going back to that graph. How many tigers left were in India in 1960? So we're going to check, this is 60 on the x-axis, and you're going up and you see that point right here. Right here. So that's the point which we see it. So we need to read that from the graph. So it looks like it's about, I would say, 21,000. So in 1960, that means on our graph, x will be equal to 60. And from the graph, it looks like this is about 21,000. But what we're going to do with that equation, when we have y, it's equal negative 350 x plus 42,000, I want to be more specific. I don't want to read those information from the graph because it's not the perfect point. It looks about 21,000, but let me just replace x with 16 and solve for y. So we have y, it's equal negative 350 times 60 plus 42,000, and we're getting 21,000. So again, I was correct with that, but again, it wasn't easy to read it because I would say, okay, it's between 21,000 22,000. So there were 21,000 tigers in India in 1960. About, so we are approximating. Okay, so that was part A. Part B, I will show you the graph in a second. Part B will be use the equation y is equal negative 350 x plus 42,000 to estimate the number of tigers in 2015. So now we're talking about the year 2015. So just remember that since X represents the number of years since 1900, so we have the year 2015. So our X, which we're plugging into the equation, will be 115. So 2015, it's 115 years since 1900. Okay, so now we're going to use the equation y is equal negative 350 x plus 42,000, and you're going to replace x with 115. So not 2015. Just remember, 2015 is 115 years since 1900. So to estimate how many tigers left were in India in 2015, we're replacing x with 115, and just let's evaluate that, and we're going to end up with 1,750. Okay, so there were approximately 1,750 tigers left in 2015. Okay, so I'm not saying this is that's the information was being checked. Okay, we're just using the problem. So C, okay, in part C, you have to find the slope of the line. So find the slope of the line and interpret the meaning of the slope. So what is the meaning of that slope in terms of the number of tigers and the year? Okay, so let's talk about solution. Okay, so we're going back here to our graph. Okay, so this is our graph. We see the equation y is equal to negative 350x plus 42,000. And from the equation, we can read that the slope is equal negative 350. But we need to explain exactly what is the meaning of that slope being equal negative 350. And the negative number definitely makes sense because we see that our straight line decrease, which means the amount of tigers left in India decrease. Okay. So we know that the slope is negative 350. Don't forget that the slope has a meaning the rate of change. So that means that tiger population is decreasing by 350 tigers per year. That is the meaning of that slope. Okay, so let me just write this down. So slope is a rate of change, which means the meaning of that slope is that the tiger population is decreasing by 350 tigers per year. Okay, which is a lot. Okay, and let's do one more, D. In D, I want you to find the X-intercept and then when you find that X-intercept, interpret. Tell me what is the meaning of that X-intercept. Again, tell me the meaning of the X-intercept in terms of number of tigers. Okay, so let's talk about the X-intercepts. So a couple things, okay? You guys have a nice graph right here, but look what happened. From this graph, I can't tell what is the X-intercepts. It looks like it may be X equal 120, but since my graph does not touch X-axis, again, I don't want to estimate that. So what is better? Use the equation which represents the amount of tigers left in India, and find the X-intercepts from the equation. So I'm going to find the X-intercept from the equation. So we have equation for amount of tigers is y equal negative 350 x plus 42,000. So find X-intercept means make y equal 0 and solve equation for x. Okay, so we replace y with 0. So we have 0, it's equal negative 350x plus 42,000. We're going to solve for x. I will subtract 42,000 from both sides. So we have negative 350x, it's equal negative 42,000, and divide each by negative 350. And that will give you that x is equal 120. Okay, so x is equal 120. Okay, now let's interpret that x-intercepts. Don't forget, just remember that X means years since 1900. Okay, so when you have that X equal 120, that means that X-intercept, real one, okay, the real X-intercepts will be is 120 years since 1900, okay, which means X is equal 2020. So we are in year 2020. And what is the meaning? The meaning of X-intercepts, if you guys will go back to the graph, will be 120. So the Y, when we on X-intercepts, the Y coordinates equals 0. So that means Y represents the population of tigers. So that means in 2020, the population of tiger will be 0. So that will be, there's no tigers left in India. This is the meaning of the X-intercept. So X equal 2020. Again, the X-intercepts, which means point 2020 on the graph, comma 0. Okay, X, and this is Y. So the meaning of that X-intercept is that in 2020, we right now in 2020, the tiger population in India will be, or is, again, will be 0. Okay, I will have to check that how many tigers are left in India. This one, again, is the correct equation, but this is how we're solving those type of problems. So next, what we're going to do, we'll practice similar problem. So next one will be skills practice, which is very similar problem to the one which I went over. So let me show you that problem. Where is that problem on the PowerPoint? Okay. Oops. I see this PowerPoint missing some stuff. Okay. It's missing the graph. Oops. Hold on, let me pause that video. Okay, guys. So I'm going back. Okay, so this is the problem which we're going to solve it. So skill practice, this is from your textbook. So we have the cost Y for a local move by a small moving company is given by the equation Y is equals 60x plus 100, where x is the number of hours required for the move. A. How much would be charged for a move that required 3 hours? Okay, so we have the equation Y is equal 60x plus 100, and we know that x represents the number of hours required for a move. Okay, so how much we'll pay and Y represents how much we're going to pay to a moving company. So how much would be charged for a move that requires 3 hours? So here, for part A, we know that x is equal 3, and you're going to use that equation and replace x with 3. So we have 60 times 3 plus 100, and that will give us 280. So we'll have to pay 280 for using the moving company for 3 hours. Okay, so that's part A. B, they asking how much would be charged for a move that requires 8 hours. So 8 hours again represents x. So in B, x is equal 8, and you're going to do the same move. You're going to replace x from the equation with 8. So we'll have y is equal 60 times 8 plus 100, and that will give us 580. So that means for 8 hours, the moving company will charge us 580. Now, C, in part C, they asking what is the slope of the line. So the slope of the line is the coefficient which we have in front of x, which will be 60. Okay, and what does it mean in the context of this problem? So what that slope equals 60 means. So don't forget that slope represents rate of change. So 60, it's the coefficient in front of x. X represents of hours. The number of hours required for the move. So 60 means that the moving company charge 16 dollars per hour. Okay, so they charge us $60 per hour. So let me just write this down. Slope equals 60 means for each additional hour of service, for each addition hour of service, the cost of move goes up by 60 $60. So technically they charge $60 for each hours of service. And D, find the Y-intercept. So Y-intercept, straight from the equation, it's 100. Y-intercept is 100. So the meaning of this is 100 does. Okay. This is the Y-intercept. Okay, 100 does. And what is the meaning of that Y-intercepts? I mentioned to you that Y-intercept is the coefficient, the number it stands by itself. So that 100 does here means that the moving company charge us 100 dollars. It's like a one-time fee, probably the driving cost, and this is the fee which they charge just for showing up. That 100 dollars, it's not how much they charge you, how much they charge per hour for service. This is just a fee. Okay. So Y-intercepts, which is 100, is a one-time fee. The company charge. In addition to the hourly rate. Because that slope, again, it's even better to write that slope is just hourly rate. Okay. And that's it. And I have one more problem for you guys. Okay, so just give me a second. Cha-cha-cha. Okay, so this is example from your textbook. Again, this is section 11.6 for problems involving slope-intercept form. This is example 2 from page 683. So here we have a graph. Let me read the problem. The monthly sales of hybrid cars sold in United States are given for a recent year. The sales for the first 8 months of the year are shown in the graph. The value x represents January, x equal 1 represents February, and so on. Okay, so this is important that on the x-axis we know that we're dealing with months. So x equals 0 represents January, so x equal 1 will be February. So we can just put it January, this is February, March, April, May, June, July, August. Okay. And on the y-axis, we see the number of cars sold each month. Okay, so we see that this line, it's the line which rises up, so the slope will be positive, and that also means that the number of cars sold each month, it's increasing. Okay, so what we want to do here. Okay, let me just go back to that problem, what they asked to do it. Okay, so let me just copy and paste that. No, that's not this one. Right here. Okay, so this is what we're going to work on it. Okay, so I want to explain that problem. Okay, so A, use the data from the given graph to find linear equation that represents the monthly sale of hybrid cars in United States. So look what happened. Here we don't have an equation. So we need to create the equation. Okay, so A, that will be the solution. So we need to write the equation in a slope-intercept form. Okay, so what we're going to do. Okay, this problem will be a little longer. So first what we need to do, we need to find the slope using the formula y2 minus y1 over x2 minus x1. So we're going to find the slope between 2 points. So they're giving you 2 points in this problem. They give you the first point 0, comma 14,400. And the second point is 5, comma 23, 400. So label them as x1, y1, x2, y2, and just find the slope. So we'll have m is equal y2, which is 23,400 minus 14,400 divide by x2 minus x1, which is 5 minus 0. So we're going to find that slope. And that will give us 1800s. So we have 1800. Okay, so that's the slope. So we have 1800. Now, what you need to do, you need to find B, which is the y-intercept. And actually, the y-intercept in this problem, it's given because that's the point right here on the y-axis. So again, like you see, 0, comma 14, 400. So this is your B. So B, the y-intercept, it's equal 14,400. So I can create the equation of this line. So it will be y equal slope, which is 1800, x plus y-intercept, which is 14,400. So this is the equation, okay? So that was part A. B, use the linear equation in part A to estimate the number of hybrid cars sold in August. Okay, so in August, guys, on the graph, in August, we see that we dealing with this point, okay, right here, okay? So we're trying to figure out how many cars they sold in August. It looks like it will be more than 25,000. Again, let's just use that equation. So August, again, that means X, that's part B, solution B. That means X equal 7. So you're going back to this equation, which we just create, and you're going to replace X with 7. So we have Y, it's equal 1800 times 7 plus 14,400. Okay, so let's calculate that. 1,800 times 7 plus 14,400, that will be 27,000. Okay, so that means they sold 27,000 cars in August. Makes sense on this graph that can be 27. Okay, so they sold 27,000 of cars in August. Okay, so that was this problem. And I have one more problem for you guys. So just give me a second to copy this problem. Okay, so here, this is the last example. We have to write a linear model here with the given information, which is fixed value and rate of change. So the problem is this. It's also from your textbook. The monthly cost for a minimum use cellular phones is $19.95 plus 10 cents per minute for all calls. So this is going back to old-fashioned way, the way cell phone companies were charging. Again, they used to charge per minute, plus we had just that monthly one-time fee. Right now, most of us has just unlimited minutes, which makes sense, okay? But let's just go back like 20 years back in the past. So what we need to do, A, write a linear equation to compute the cost C of using T minutes. So linear equation, they want you to write the equation using slope-intercept form, which is y equal mx plus b. But in this problem, y will be C, which will be cost, and x we're going to replace with t, which will be amount of minutes. So it's going to be mt plus b. Hopefully that doesn't confuse anybody, but they want to use C for a cost and T for time. Again, C cost, T time in minutes. Okay, so A, we need to create that equation. Okay, so we need to find M, which stands for slope, and the rate of change. So in our problem, M, our slope, will be 0.10 per minute. That means, again, this is the rate they charge. They charge 10 cents per minute. So rate of change, in our case, how much they charge per minute. Okay, so our slope, it's 0.10. Okay, so 0.10, the slope, it's always how much they charge per hour, per minute, in this case, per minute. Okay, so we know M. Now, B, which is the Y-intercept. But the meaning of Y-intercept in the word problems, that means that one-time fee, or one-time fee, one-time charge. So this cell phone company, they charge you $19.95. That's how much you used to pay monthly for your phone, plus 10 cents for each minute of phone calls which you made. So B, which is the Y-intercept, one-time fee will be $19.95. Okay, so B, it's equal. So just remember that Y-intercept in the word problems is always that one-time charge, one-time fee. So we can create that equation. So the cost will be M, which is how much they charge per minute, which is 0.10, 10 cents. T represents minutes, plus one-time fee per month, which is $19.95. So this is the monthly cost of use of a cell phone. So that's part A. Now B, use the equation to find the cost of using 100 minutes. So now we're using 100 minutes. We use in a month 100 minutes. That means that 150 minutes, that's your T in the equation. So to figure out how much we're going to pay if we use the phone, I mean, we make phone calls and we spoke 150 minutes on the phone, we're going to replace T from the equation with 150. Okay, so the charge will be C, it's equal 0.10, 10 cents times 150 minutes plus that one-time fee, which is $19.95. And that's going to be equal 34.95. Okay, 34.95. So cost of using 100 minutes is $34.95. Okay, so that's it from section 11.6. I show you a couple problems, application of linear equations. So that's why we're learning them. To be honest, nobody in the real life, so I'll just grab random linear equations. We're actually using them every day in application, the problems like we went over. Okay, so thank you for watching and have a wonderful week.